Hey everyone. So, what if I told you that you could unlock the core patterns of coding interviews and build some serious confidence just by mastering 20 specific problems? It sounds almost too simple, right? But it's an incredibly powerful strategy. Let's break down exactly how it works. You know that feeling? You open up a site like LeetCode, you see literally thousands of problems, and you just get this wave of panic. It's totally overwhelming. It's a classic case of analysis paralysis. I mean, where do you even begin? Well, the answer is not to just start brining through hundreds of random problems. The real secret here is focus. And the magic number? It's 20. And that's the promise here. We're going to walk through the foundational problems that teach you the core patterns you're going to see over and over again. This isn't about a checklist. It's about building a real, deep understanding and the confidence that comes with it. So I want you to think of this differently. This isn't a list of problems to memorize. It's about building your own personal toolkit. Each one of these problem types is a tool, a pattern that you can then use to solve a whole bunch of challenges you've never even seen before. So what's actually in this toolkit? We've basically organized our 20 problems into 5 main trays. We've got hashing for super fast lookups, stacks and queues for managing data in order, pointers for efficient traversal, the classics of searching and sorting, and of course, dynamic programming for tackling those really complex problems. We're going to focus on just a few key examples to show you how this all works in practice. All right, let's open up a few of these trays and get a closer look at the tools inside, because understanding how each pattern works is really the first step to mastering it. First up, the hash map. This is your absolute go-to tool for any time you need to store something and find it again instantly. Think of it like a magic dictionary. On average, it gives you what we call O of 1, or constant time lookups, which is just a fancy way of saying it's incredibly fast. Now here's a perfect way to visualize this, especially for the classic two-sum problem. Imagine you're keeping a running ledger. Your goal is to find two numbers that add up to a target, right? So for every number you see, you figure out the other number you'd need to hit that target. That's its complement, and you just jot it down. The very moment you see a number that's already on your list of needed complements, boom, you found your pair. It's that simple, elegant, and super fast. And this right here shows you the power of a single pattern. That one idea, using a hash map for quick lookups, doesn't just solve two-sum. It also lets you instantly check for duplicates in a list, or efficiently count up characters to see if two words are anagrams. It's one tool, and right there, 3 foundational problems are solved. Okay, next tool in our kit, the stack. The principle is dead simple. Last in, first out. Or LIFO. The very last thing you put onto the stack is the very first thing you have to take off. And to make that really concrete, think about the valid parentheses problem. Imagine you're stacking plates at a buffet. Every time you see an opening bracket, like a parentheses or a curly brace, you add a new plate to the stack. When you see a closing bracket, you look at the very top plate. Does its shape match? If it does, great, you take it off. If it doesn't match, or if there are no plates left to check, you know the whole sequence is invalid. Now let's talk about one of the most elegant techniques out there. 2 pointers. This lets you process data, usually an array or a list, in a single pass by using 2 different pointers that move through the data. It's just incredibly efficient. So how does this work for, say, reversing a linked list? Well, picture a train. You've got your original train, and you're building a new one in reverse. You just take the first car from the old train and make it the new head of your reversed train. Then you grab the next car from the old train and you stick it at the very front of your new one. You just keep doing that until all the cars have been moved. That's it. That pointer magic is the whole algorithm. And of course, we've got to talk about the classic binary search. Now, the absolute key here is that it only works on sorted data. You look right at the middle element. Is that your target? Probably not. So is your target bigger or smaller? Based on that one answer, you get to throw away half of the entire data set. You just repeat that process, having your search space every single step. It is ridiculously fast. So why are we even learning all these patterns? I mean, is it just to pass an interview? No way. These concepts are the actual, fundamental building blocks of the software that pretty much runs our world. Seriously, these patterns are everywhere in the real world. Hash maps, that's what makes your caches and database indexes so blazing fast. Stacks, they're essential for how compilers understand the code you write. That 2-pointer technique is used in real-time data streaming. And binary search is the backbone of countless database lookups. So mastering this isn't just theory. It's practical, professional-grade knowledge.
Okay, but to become a true craftsman, you have to go one level deeper. It's not just about finding a solution. It's about understanding why one solution is better than another. And that means analyzing the trade-offs. Let's take the maximum subarray problem. There are a few ways to solve it. Cadin's algorithm is this beautifully simple, single-pass solution. Its time complexity is O of n, or linear. But you could also use a divide-and-conquer approach. It's a great way to understand recursion, but it's slower, at O of n log n. The master knows both, and more importantly, knows which one to choose and why.
And this chart just drives the point home. When your input size gets really big, the difference between O of n and O of n log n isn't just a little bit, it's enormous. Choosing the right algorithm can be the difference between a system that flies and one that just grinds to a halt.
Okay, so we've covered the tools, the patterns, and the whole philosophy behind this. Now let's put it all together into a clear, actionable roadmap just for you.
Here is your plan, boiled down to 3 key things. Number 1, stop memorizing solutions and start understanding the patterns behind them. Number 2, don't just write the code. Learn to analyze its time and space complexity so you can explain the trade-offs. And number 3, a great solution always handles the tricky edge cases. So always think, what could go wrong here? What if the input is empty?
So we've laid it all out. You've got the list of 20 problems, you get the core patterns they teach, and you know the mindset you need to have. You officially have the map and the complete foundational toolkit. The only thing left to do is to start. So my question to you is, looking back at that toolkit, the hashing, the stacks, the pointers, the searching, which one of those tools are you going to pick up and sharpen first?